Hello and welcome. My name is Fabrizio Petrozzi, and I'm going to be presenting on the Hyperparameter Optimization Framework, Optuna. As a quick refresher, and before we begin with the presentation, I'd like to go over two concepts that I think are important to understand the rest of this presentation. First is the parameter. These are values that the model learns from the data, such as weights and biases. Then, we have the hyperparameter. These are settings that we choose before training, and they're going to determine how the model learns, including learning rate and epochs. So how do you choose hyperparameters? Usually, it's through trial and error. In this simple example of defining a model, we've used trial and error to find the layer sizes, the dropout rate, and the learning rate. At the end of this first trial, you may get a decent accuracy, and by the 10th trial, that might improve. But after many more trials, we are unsure if that accuracy will improve or worsen. That can be pretty frustrating and manually intensive, but luckily, there's a solution to this. Introducing Optuna. If you were the previous user and you used Optuna, then you would have the benefit of automation. So here is the code again, except this time we're using Optuna to suggest hyperparameters. We provide ranges for the layer sizes, increasing or decreasing by steps of our choice, the dropout rate, and the learning rate, as well as the optimizer. Then, Optuna is going to take these values to build a model. After that, it's going to choose an optimizer with some pretty simple if-else logic. If it's Atom, use Atom. Otherwise, use RMS prop. The great thing about Optuna is that in just a few runs, you can get pretty great accuracy. So now let's go over a practical example using the telco customer churn dataset. This dataset includes 7,043 rows and 21 columns. It goes over customers who left within the last month, services that each customer has signed up for, customer account information, and demographic information about the customers. The target variable is going to be churn, 1 if the customer left, and 0 if they stayed. I ran dataframe.head to visualize the dataset, and after one hot encoding, this is what the results look like. To prepare the environment, I imported various libraries that are typically used to create and evaluate models into Google Colab. I also installed Optuna, imported Optuna, and from optuna.pruners, imported median pruner. More on pruners later. Now for pre-processing. First, we load in and pre-process the dataset. We split the features in the target, and we do train validation split, as well as standardizing the features. Then we create the data loaders with a batch size of 256, since we don't want to load in all 7,000 rows of data at once. And then we convert to PyTorch tensors. Building with Optuna. So first, we define the model, similar to the previous example, except this time I've used different values to provide us better results for this dataset. This is the dropout rate, learning rate, and the optimizer. The rest of the code will be the same. Optuna is going to take these values, build a model, and then it's going to choose an optimizer. How Optuna works. Optuna is going to choose hyperparameters, building a new model for every trial. Then we're going to define the loss function. In this case, it's binary cross-entropy. And we're going to train the model for 40 epochs. Now, we're going to use standard model training, except it's going to be done for every trial with changing hyperparameters. We're going to evaluate the validation loss after each epoch, and we're going to report the progress to Optuna so that it can keep track of how a trial is doing over time. If Optuna believes that the performance is bad, it's going to stop the trials early, saving us some time. Then it's going to return the loss, using this value to rank the current trial compared to others. Visualizing the magic behind Optuna. This is what random search looks like. What Optuna does differently is it focuses on its successful trials, making more trials where it has had the best results. Pruning will end trials if it seems like they will perform badly, saving time and resources. Optuna in action. In study, we're going to track all of the trials. We're going to ask it to minimize loss, and we're going to start pruning after 5 epochs. This happens so that the model gets a chance to warm up before pruning begins. Then we're going to run it 50 different times with different hyperparameters, and we're going to save the best parameters inside of best underscore trial. Now this is what it's going to print, and here's an example of trial 7, where we have these values. It's going to let us know what the best trial has been so far and what the loss value is. It's also going to let us know if a trial has been pruned. After all 50 trials, it's going to give us the best trial with a validation loss and the best hyperparameters. And so far, this model has done pretty good. So how did it do? If we want to evaluate our model with more than just loss, then we can rebuild it and retrain it. We're going to rebuild it using study.best_params, which is going to use the best parameters that we got from the study. And then we're going to train the final model using those same parameters. This is done in order to evaluate it properly, and also because Optuna's trials are temporary. So if we want to create a final version with those parameters, then we have to rebuild it. Then we're going to print these evaluation metrics, and these are the results. These are pretty great results for only having run the model, adjusting the hyperparameter ranges once. And as a bonus, if you're not happy with those results, you can use matplotlib to plot a graph for the importance of each parameter. Using this, you can adjust according to the importance to improve your results. The information I have presented today came from research I took part in for my deep learning class. The information was relevant to the class. But if you would like to learn more about Optuna, there are topics such as its eager search spaces, the state-of-the-art algorithms, and also for its easy parallelization that you can find online. So if you're interested in learning more about Optuna, then visit optuna.org for more information. Thank you, and have a great day.